Right, I would begin section 4F with brief introduction to multiplication of vectors. And first, some review. Say, given two vectors, we have seen we can do this, and we can do, subtractions of two vectors geometrically. This is what we're talking about. Okay, and then of course for subtractions, and the big question is, can we then find a definition for multiplication of two vectors, a product of two vectors? That is, we have numbers. If you have numbers, 1 plus 1 you get 2, and 2 times 3 you get 6, things like that. So how about vectors? Is there definition? In fact, it turned out they actually two types of multiplication that we can perform. First type multiplication, let's call it a scalar. Instead of calling it multiplication, call it a scalar product. Okay, and it's defined as, suppose you have a vector A and B, and so the scalar product of these two vectors is defined as A dot B, written as follow. We'll talk about that later, more about this later. And the other one is called vector product. And we represent the product as follow: A, right, like X, but it's a cross. Okay, A cross B. We say it's A cross B, and this is A dot B because of the dot here. And there's one major difference, and that is, if you perform a scalar product, you get a value, then it can be a 4 or whatever. And you perform a vector product, you essentially get another vector. Okay, so A cross B gives you another vector, A dot B gives you a value. And the definitions is given here. Scalar product AB, also known as a dot product. You know why? Because there's a dot here. It's defined as follow. Now, what does that mean? Look at one example. Let's look at A, right? So A dot B is a 2, 1, 3 here. Dot negative 1, 1, 1, and means you multiply this, you get negative 2. The second one plus 1, just follow this, and then the third one, 3 times 1, 3, and find the sum of all the products of each component, and then you have so you had 2. Right? Isn't it nice? Pretty simple. And there's another definition, geometric definitions of dot product. Let me show you right here. If data is the angle between these two vectors A, B, then A dot B is defined as follow. Now, how do I show this? I can show this geometrically. We have a vector A and a vector B, and both of them animate from the same point, and surely they made an angle. It could be 0, could be 180, 90, but suppose that's any angle we talk about. And so this is what we talk about. If we know AB or data or whatever, then we can then they will fit into this relationship basically. And this is a very useful relationship. We'll talk about that later. So move on to this to look at the more properties. Right here is the more properties of a dot product. The first one is a commutative property. So A dot B is equal to B dot A. Immediately we put that into action. Let's do part B. So B dot A. So what is B dot A? Do we need to perform the operation again? Although it is simple, we realize that, however, according to this, then A dot B is actually B dot A. Is equal to A dot B. Now we have already calculated a dot b earlier, and if you recall, the answer was 2. And how about this one? This means that first you find the magnitude of a, then you square the number. Now while it's not difficult to do, finding the sum of a square and then square root a and square is not an easy task, but we do know that this is actually equivalent to a dot a from this one right here, property. And so this do this and dot this. This is much faster because usually you can do this by observations. This is 4 plus 1 plus 9, and then this is 14. That's why inspecting this you get 14 easily, right? And so look at last one here before we end this. This part will be this first part of and right here ijk, a different way representing a vector. So where's I? Yes, you're right, because the component I is a 0, so that's why you don't see I here. And if you want to make it clearer, this is 1, 1, negative 1, right? It's dot 0, 2, 1, and so the rest is very simple. You can now probably see that 0 is 2, this is plus negative 1, and the outcome is 1. As simple as that. I will urge you to try the others and do the other problems, say problem 3 and 4, and we'll see you again later in the second part of the of this section. And all the best.